This presentation is called Harvesting Trust, Methods for Validating Chatbots in Agriculture. I'm Serg, and Yannick is going to follow during one of the largest sections of this presentation. So let me start with table of contents. So first, since trust has a lot to do with quality and validation, of course. First, we're going to talk about why is quality assurance or assistance important, and then how do you do that with large language models? Then a little bit of background information of what we do in agriculture, what does Syngenta do in general, and then we'll go into the the meat of this presentation, which is how do you validate agentic AI, or what's our approach for that. So why quality? So we've heard quality in a lot of industries in software development, and in particular, it's important in many ways, and we could talk about responsible application of technology, ethical concerns with quality in all sorts of situations, with products, with technology, with businesses in general. But even from a completely, selfish standpoint, you know, uh, good performance, good quality drives trust, and trust drives adoption. If we look at, how hype cycles go as a technology starts, it starts with an innovation, it goes to a peak of inflated expectations where it doesn't meet the standards of what people are looking for, and then there's a chasm. And we can see the same with adoption. As adoption starts, there's a group of innovators that are going to adopt any technology no matter what, and then early adopters. And then there's a chasm, where it doesn't grow because people don't believe in the technology because, they haven't seen the kind of results they're looking for from that technology. And once you end with the chasm, there's some disillusionment, and then it starts to grow. And that's when you get to all the majority of adopters. And it's only towards the end of the process, you get people on board that, pretty much since most of the people are using that technology, they just hop on the bandwagon at the very end. But that's pretty much how this all goes. And quality has a huge amount of to do with this, especially during the chasm. Because and that's pretty much where we are with AI. You would think that most of the world has stopped the technology, but it's not the case. Um, not the way you would expect. So then there's also how do we assess quality? And quality is something that is assessed quantitatively. And so you pretty much, like the adage goes, you cannot improve what you can measure. And how do we do that in AI? We do that through metrics, and primarily just very few metrics drive the discussion. And that's kind of a shame because it's a lot more complicated. If you think about it, with quality assurance, it all started with an assembly line. That's how quality started. So at the end of the process, you would end up with a bag of chips or whatever it is you were building, and you would weigh it, and you say, okay, is it the right weight? And that was the metric you were trying to figure out. Okay, if the bag of chips has the right weight, then it passes the test, and then you send it off. But it's a lot more complicated than that, and quality has become something you assess at different stages, involving a lot of different methods. So when we're talking about, AI, in a lot of software scenarios as well, you're only talking about performance. And in that case, it could be accuracy, it could be a lot of different metrics that come into play, it could be relevance, a lot of things like that. Uh, and then, but there's a lot more to it. You have to check for reliability. So how often does the performance metric deviate from, a standard, or a baseline? And then there's operational efficiency. How quickly is it finished? Then you identify weaknesses and figure out in what ways does it fail, and sometimes beyond, the qualitative ones as well. And then there's also the question of user experience. So there's a lot of different things we should evaluate, but we don't. Um, and And then we also have to talk about, okay, there's a lot of things embedded in the culture of quality that we have to, a lot of dimensions that we have to separate. There's of course the testing. And testing is something that's done with code and design, and it's mostly focused on detecting, detecting bugs, detecting issues. And the idea behind it was, for test engineers and developers to do it. And upon release, that's equivalent of, the end of the assembly line, doing a test there. Then there's quality control, and it's more like a holistic approach on the entire product, and it's about verification. It involves the entire team. It's done before release. And then there's quality assistance. That involves the whole process. It's about prevention. It involves the entire organization, so it's a shared responsibility. And and so that's where we should be at. Pretty much, well, quality assistance involves quality control involves testing. So one constant is bigger than the other. And that's something we should take into account. And with all of these things, to do it well, productivity is key. You should be about early design, so finding bugs before writing any code with design sessions and kickoffs. So the idea is to, okay, figure out in what ways could your product fail and anticipate those failures. And then comprehensive team involvement, empowering developers to each one get involved with quality testing. And then, of course, making sure that the whole process is involved in continuous integration. So have that mindset that all your tests are going to be continuous. They're not going to happen once. And of course, testing is not something you have to get perfect. Quality is not something you're supposed to get perfect, from day one. It's something you have to build upon. So in the same way that we have, I don't know if you've heard of the concept Maslow's hierarchy of needs, you kind of build upon. You can't feel safe till all your physiological needs are met. You can't feel love till you're safe, and you can't actualize till you have everything else. So the same thing with quality. You have to make sure you have a deployable product. It has to be secure, it has to be usable, and then it's useful, and then it's successful. So you build upon these things. And so now the question is, how do we relate this with large language models? So anybody can build a chatbot. In reality, that's not something, it's not something too hard for any developer these days to build. It just takes a little bit of code and they build one. In fact, you probably don't even have to be a developer. Here you have 40 lines of code that can, create a chatbot from zero. All you need is a topic, you need an API key, and you can get one for Anthropic, you can get one for ChatGPT, and you're off to the races. And these days, you probably don't even need that. You could get some kind of tool that you install on your computer, and you can, use it that way as well with API keys as well. So it's not hard at all, but that doesn't necessarily mean you can trust this for every kind of use case. We've all seen the benchmarks, and these benchmarks is, you could say, well, it's been tested because, we have all these tests, and they say, okay, it's 86% correct on this and 50% correct on that, and that might be good enough. But mind you, this is pretty much like, doing the Olympics, and they're good for bragging rights, but they don't necessarily mean they work outside of the scenarios that were tested. So that's equivalent. Okay, this is the fastest runner on 100 meters, but that doesn't necessarily mean that they can swim, right? So we have to put that into context. And we also have to realize that large language models are inherently, flawed. They're not meant to be a good representation of everything that is language, or everything that language is supposed to represent in the world. And that's due to the fact that it is, in a way, lossy compression of all, or a lot of the language on the internet. So, you could, it varies from model to model, but it's anywhere between 40 and 4,000 times smaller than the text that, that was used to train it. So that's the equivalent of, say you took a, a map of the entire world as an image, as a raster image, and you reduced it by that same amount. Maybe the map had a lot of detail to it, and once you zoomed in, you couldn't see the villages anymore. You couldn't read the text, for the images anymore because it was just too blurry. Um, you would expect that with large language models. When you compress it, a lot of the knowledge that is not as represented is going to be blurry. And that's probably like a very oversimplified, characterization of what it means to compress it. But uh, the gist is that. The other thing that makes it flawed is it's stochastic. They employ random sampling during the generation that leads to inconsistent outputs, which is why you can ask the same question 10 different times and you get 10 entirely different answers. And that's by design. Also, it is biased. Training data is not representative of all human activities or populations. Evaluation biases even further. So what this leads to is that you'll just lead to issues with accuracy, like misrepresentations, hallucinations, simplifications, misrepresentation, consistency, like variability, unpredictability, discrepancies, drift. And by drift, I mean it's not going to necessarily have the same kind of answers today as it will have in a year, even the same model. And so that leads to this unpredictability that we tend to have. Um, Next, I mean, just to kind of give you an idea, we'll put a pause on large language models and we'll discuss them further in this session. But just to give you an idea of how AI is used in agriculture, because it's pertinent to what we're going to discuss with our agentic AI, is it's used quite a bit in a lot of different areas. So it's used in research and development, such as designing seeds to protect crop against disease, floods, and droughts, and that sort of thing. Uh, Planning and simulating trials. We conduct thousands of trials throughout the world, and then generating new chemicals and what is called time biologicals, which are like biological entities to combat plant diseases and pests. It's used quite a bit to formulate those approaches. Um, it's also used to monitor and predict soil health. So we work on revolutionizing soil health monitoring with AI, and also precision soil analysis services are also keep the sort of things that are made available to our farmers through our systems. And then lastly, we have a tool called CropWise, which is part of what we're going to discuss today. And so that CropWise is what is called a digital farming tool. Well, it's more like a suite of tools, and the whole point of these tools is to assist farmer decision making. So once the farmer has our other products, whether it's seeds or it's like chemicals or biologicals to protect their crop, they still have to decide when to use them, how to use them, or things like when to plant. And so we have for assisting decision making models to predict disease and pest risk, to detect crop disease, to recommend products, to decide where to apply their products on the field so it's done in a sustainable fashion. And so that's pretty much what we do. Yannick and I, we work in the part of the company that works on these products to help farmer decision making. And then lastly, the part we're going to discuss involves a new product we came out with called CropWise AI, and it's a conversational agent, and it's to assist farmer decision making by agentic AI to deliver all and any digital agronomy capabilities to the farmer. So what I had discussed here, all these tools that already exist, all these models and recommendation engines and so forth, where the idea is to make them available through a conversational agent, so that a farmer can more easily be able to combine all these different insights. So next, I'll allow Yannick to continue the discussion on how to.
Thank you, Serge, for the first part. So as explained by Serge earlier, we know that if we are not able to improve something if we cannot measure the output of it, and that's exactly what we know in case of agent and LLMs models. So in case of Cropwise AI, I'm going first to describe what is the Cropwise AI agentic AI we developed with Serge and the team. Describe quickly the different actions the AI can do, and then I will go deep into how we perform evaluation on this agent. Can you go to the next slide, please? So Cropwise AI agent has a big 10,000 feet pictures. We have a grower that trigger a conversational agent, and this conversational agent is going to trigger foundation models, and this foundation model is going to directly trigger some action group or tool types. And we have different type of tool types. We have APIs one, the RAG one, and repel, where all of these action can do specific stuff. And we orchestrate all of this operation via instruction we feed into the conversational agent and into the LLM. So why do we have different tool types? Is because we want to have the ability to have function that can do specific action according to a user question. So can you go to the next slide, please, Serge? So we want to be able to address the customer or the grower needs via different action rules, because one generic agent can be good to provide generic answer, but in our case, we want to be able to provide very specific answer to very specific problem, such as, okay, what is the seeds I need to plant on my fields? I need to know the localization. I need to know what I planted previously. So I really need to gather specific information. And for example, an API can do that, because internal API we have in our team can get access to this information. So the API tool is farmer specific, location specific, which is very important. It can be also time sensitive. It can also predict depending the type of API, and it can be descriptive. But the farmer can also ask general question about description of a given product or of a given seeds, for example. And in that case, the API might be not the good tool to do that. But the REPL, which is a framework built by Serge, where you have a text converted into a Python that is being executed to query some data and perform some operation, is great to do that. So we also implement this kind of tool type. And then we also have RAG system, where it's not really farmer specific, location specific, but it's very good if we put some product information to retrieve this information to the question from the grower, and very good to add some description. So here we highlight some sources we have. So in API, we have Insight Engine, which is the model orchestration we have in our team, where we host all the model, and there is an orchestration layer to determine which model can be used. And we host all of our models as an API. For the REPL, we are using as a sources Golden Harvest, which is internal Syngenta services, where we have all the seeds variety trait, and we have some seeds recommendation, especially for corn and soy in the US. And then Syngenta Tribe is a general services where you can find a lot of documentation for internal product and seeds. Sorry, can you go next, Serge?
Yeah.
So what is the evaluation strategy we want to have? As I explained, we have an agent with different action group for specific action. But in case of evaluation, we don't want to have a generic evaluation, not only the output. We want to be able to evaluate every component. So we decided to have 5 specific points about our evaluation strategy. The first one is we want to have a custom ground truth database that we can update and that we can have, like as explained by Serge earlier, a continuous improvement process where we have a set of questions, we evaluate it, but maybe a product owner or maybe a domain expert can also populate this ground truth database by adding new domain knowledge we want to evaluate some specific question on. The second point is being able to handle non-deterministic output. This is what also Serge mentioned earlier. LLM is non-stochastic process. So you can ask 10 times the same question, you might have not always the same answer. And that's something we want to be able to evaluate as part of our framework. As I already mentioned, the third point is handling multiple components. So we have API, we have RAG, we have REPL, but we also want to be able to evaluate the end-to-end agent. And this involves something that we see in the fourth point, which is need to track parameter change. So we have the number of questions that we have in the ground truth database. We have the agent version. We also have the action group version. We have some parameter within the agent. And all of that is a set of parameters that can change. And we want to be able to edit and provide a performance score for individual component as well as for the end-to-end agent for a set of parameters. But if we change a parameter, we want to be able to regenerate the evaluation end-to-end pipeline to provide a new score. And all of that comes up to the last point where we want to have a scalable framework, because as explained, the ground truth database can change, but also the number of tools we have as part of our agent. We can have more APIs, we can have the RAG system that is improved in terms of documentation, we can have multiple REPL, we can have another agent where we are changing the foundation model, for example. So that is our strategy. Can you go to the next slide, please? So here, I would like to pause and discuss about evaluation methodology, where we have the complexity versus the speed. We have different methodology that can help to evaluate LLMs more efficiently. Just we have as an automating software testing, there is trade-off between complexity and speed. So sourcing judgment for evaluation models is evolving with new approaches. Everything is changing on the day-to-day basis almost. And simple rules can provide quick and cheap evaluation, while using other AI models can offer more challenging judgment at a lower cost than human evaluation. So there is also a trade-off where we want to be able to evaluate as a human, or we can also make AI evaluating AI. So AI-based evaluation are becoming very promising, with students showing high agreement rates with human judgment. For example, the GPT-4 model achieved over 80% agreement with human ratings. However, using AI for evaluation can also introduce bias. So recent research highlights the fact that results can affect AI evaluation as well. So can you go next, please? So here I want to present the high-level evaluation framework picture we have. So I will start on the top, and on the top right, you see the parameter. So this is exactly what I explained. We have the foundation model as part of the foundation of the agent, the different action group. We can also go deep into the parameters such as the temperature, the number of the top key, etc. So this is as part of the agent and the LLM. Then we have the layer of question, where we have the ground truth database, the question populated by us, but also by the domain expert, by the product owner, etc. And what we have 4 components here. We have the 4 components we want to evaluate. We have the agent end-to-end evaluation. We have the API evaluation, the RAG evaluation, and the REPL evaluation. So every component is specific questions that triggers the agent in order to perform specific evaluations. So in terms of agent, it's generic question that a user can ask where we validate the end-to-end agent workflow. But in case of API, for example, we are asking specific question and the agent is only using, we make sure that the agent is only using the API action group. We also create some specific process where we evaluate only the action group without involving directly the agent by asking this question. It leads, for example, for the API evaluation to have a score on only the API's capability of the agent. So we are able to say, okay, we know that when we ask this set of questions, only the API is triggered and we have this score. And the same logic applies for the RAG evaluation and for the REPL evaluation. So we build specific evaluation question, evaluation process for every component, as well as for the agent end-to-end. And at the end of this overall pipeline, we publish an evaluation report. that give for a set of parameters, for a set of questions, a matrix evaluation for each of the components we have as part of our agent. What we need to pay attention is we need to make sure that the question we have is reflecting what a user can ask and also covering all the scope of the action group. So in case of API, we want to make sure we cover enough all the scope of the API and the way the agent can interact with the API. Same logic for RAG and for REPL evaluation. That will ensure us that the evaluation report we're publishing is giving a number that is meaningful for us. So the benefits of this evaluation framework we created is that it's reproducible because it ensures consistent result by tracking the data, the code, basically all the parameters. We can reproduce an evaluation despite the fact we have a non-stochastic process in the sense that we have non-deterministic output. We are able to reproduce evaluation result thanks to this framework. Second part is shareable. It helps us, for example, on the day-to-day basic research to reproduce the end-to-end pipeline and being able to share experiment and also share evaluation report. And it's scalable in the sense that we can add a new action group, a new function to the agent. We will be able just to extend the way the agent is evaluated via the evaluation framework. That gives us confidence that if the product owner wants us to create a new action group, we will be able to first create it, but also evaluate it right away. So it's all customizable because we can adjust to the change in terms of data, in terms of tool, and in terms of objective. And that ensures relevance and effectiveness in our dynamic environment. And I will hand over now again to Serge.
Okay. Yeah. So what is the plan? The plan is we have a ground truth database, and we have a set of questions, and we repeat the question as many times to be able to see how much it varies. But also we're going to create variations on the very same question. At the moment, that part is not implemented, but the idea is to, for robustness testing, change the question. Because for LLM, even adding punctuation, like a question mark at the end of the question, might change the kind of response it gets, or changing one word for a synonym will do as well. So we wanna see how well it performs under these variations. So this gives us a sense of robustness. But if we keep the same question many times, this will give us a sense of how consistent the accuracy metrics we get are on each one of these instances. So we want to be able to test both things simultaneously. So that's why we have to create a lot of repetitions. And when it gets to this repetition, it goes to the agent. The agent generates what is called a trace file, which is what are the steps it took and what kind of responses it got for each one. This is sent to evaluation, and it's evaluated on all these different, depending on what tool was engaged. It will go get that evaluate the intermediate steps. So the intermediate steps was if it generates code, how do we evaluate that code? And it will also deliver other metrics such as how many tokens did it generate, how long it took, etc. And this is also part of the metrics we use to test. So now we'll go through an example. This is called a REPL example. REPL stands for repeat, evaluate, print, and loop. It's what many times is called code assistant as well. Basically, you're creating a large language, asking a large language model to generate some code, and then that code delivers some output. That output is interpreted, and that interpretation becomes the response to the question. So I'll give you an example with that's a text to SQL example. It's not what we use, but just an idea of the sort of thing we do. So say you ask this very technical question, which is I'd like a seed with relative maturity of 108 and grade die down. So it's supposed to give this answer, based on the sort of data we have. And this is the expected code, which is going to create a SQL query with this. It's a fictional kind of SQL statement because this database, the database doesn't exist as this is, but this is just part of the example. So imagine we have some regular expressions that are supposed to exemplify what entities we need from this text. And the reason we need entities is because that's how we know the text is correct. I mean, there's so many different ways of making this query, but one thing we know is that we definitely need a relative maturity of 108. So RM of 108. So that would present itself as an equals, right? And a great die down, let's say a good die down is 1 of 1. So like let's say we go dry down equals 1. So we're going to expect the code to have these entities within. And the output entities, we expect it to have this, say it's Agrisure and have this product code. So if this product code's in there, we expect it to be correct. And so when the trace file is generated, let's say it found this code. This is the code that was generated, but it said relative maturity of 108 and a dry down of less than 2. That might be correct in the sense that yes, it got all this data back, but it was far more than we needed because it had a bigger scope. In other words, it doesn't say dry down equals 1, it said dry down less than 2. So that's why we get a context entity recall of 50, because it only got 50% of these entities within. So in that sense, it's half correct. However, it did find the hybrids. It did find this information within the data it found. Why? Because since it had a larger scope, it of course within the table of return, it's going to have all this data in there, so it's going to be 100% correct. And then, however, since it didn't narrow down to a single one that matched the criteria we had defined, it got 0 because out of when it had to generate the response and looked at this big table, it said, okay, I'm just going to grab one of them that I think is good, and it didn't grab the one that has necessarily the best dry down, which is a single instance in this case. So that's why it would get a 0% right, because it doesn't have this entities within. So that's just an example of the sort of thing we're doing. Of course, we have a lot of other metrics besides context entity recall. Depending on the tool, we're using different metrics and different methods, whether it's a heuristic-based one or it's a large LLM as a judge. We're using different metrics. So that concludes this talk, and we're open to any questions.